The diagram shows three forces acting on a particle of mass 2 kilograms. We want to find the resultant force acting on the particle, find the acceleration vector for the particle, find the magnitude of the acceleration, and then we're told that the particle is initially moving at 2 meters per second in a direction directly opposite to the resultant force. What is the speed and direction 10 seconds later? So in part A, we want the resultant force, and we're just going to get that by adding the three forces. So 2, 3, 4, add -1, 1, 1, add 3, 2, -3. So that's going to give me 4, 6, and 2. The acceleration vector, since we know the particle is of mass 2 kilograms, and we know force equals mass times acceleration, 462 is going to be equal to 2a, and so a is going to be 231 meters per second squared. The magnitude of that vector is 2 squared plus 3 squared plus 1 squared, which is the square root of 4 plus 9 plus 1, which is root 14 meters per second squared. We can use v equals u plus at for this because we know that initially the velocity is in exactly the opposite direction to the resultant force, and therefore exactly opposite to the acceleration. That initial velocity is -2 because it's in the opposite direction. And then we'll just have plus root 14 times 10, which is 35.4 meters per second, approximately, given it to one decimal place. And of course, that would be in the direction of the resultant force.